So the next important question is, what is a vector? So let's try answering this question. So as we've already seen the example of the boy throwing the ball to one of his friends, which requires you to have some velocity given to the ball. So I'm using this term velocity. You would have already seen this in your 9th and 10th. You would have seen speed, and you would have seen that speed only has magnitude, but velocity has both magnitude and direction. You would have seen all of this before. So this will actually help me form a basis of your understanding here, since you already know this. So if I say that the ball is traveling at 10 meters per second, I'm talking about its speed, right? This quantity 10 meter per second only tells me that okay, the ball is able to cover 10 meter in every second. If I increase this to 11 meter in every second, that means the velocity has increased to 11 meters per second, right? It has increased by 1 meter per second. That means this is somewhat telling you how fast is the ball moving, but this is giving you no information about where the ball is moving. And in real life cases, to deal with trajectories, projections and everything, you need to take care of where the ball is traveling also, along with how fast it is traveling. So if I say that the ball is traveling at 10 meters per second towards east, right, 10 meters per second, then I'm talking about its velocity, because I'm fixing some reference direction. My reference direction here is east, west, north, south. And with respect to this reference, I'm telling that okay, that the ball is traveling 10 meters per second towards the right. That means towards east. So that's why I'm using this word east. That means I'm talking about its velocity. In this case, your velocity becomes a vector. So bringing in the traditional definition that you guys already know, a vector is something. It's a quantity which has, so instead of using the word something, it looks more professional to use. A vector is a quantity which has both magnitude and direction. So this is very simple to comprehend. Okay, the vector is something which has both magnitude and direction. What does magnitude tell you? What does this part of the definition tell you? It tells you about the quantity of the vector, like how much does the vector weigh, right? How fast is the ball moving? How heavy is an object? And everything that that's around those lines. If I take up a physical quantity, and if I'm able to measure it, and I'm able to assign some value to its measurement, that value itself is your magnitude, right? That value itself is a magnitude and gives you an idea about what quantity of the vector is present. And this part of the definition, direction, tells you where, right? We've already seen this. It tells you where is the physical quantity directed. So I think this much is enough for you to actually understand what is a vector, especially after having known the context of why we are studying this chapter using the ball boy example. You shouldn't have any sort of a doubt about what a vector is, even by its definition and also by its understanding now, because you have seen a real life example which actually helps you differentiate between this case, like the only magnitude case, and the magnitude and direction case, where you have seen how important the direction becomes. Like without the direction, you don't know where the object is moving. You can't predict about where it will go. You can't have any control about where you want it to go, right? So for all this, vectors become very important. So now I think it should be clear about what can be called as a vector and what not. Let's see, in fact, let's develop an understanding from the beginning as to where these vectors are represented. Let's look at the three-dimensional space and try to understand all this, because vector is a three-dimensional quantity. Like, I'm not saying it's always three-dimensional. Sometimes you can just represent vectors in a plane, so then it becomes sort of two-dimensional. Sometimes you can just represent vectors along a line, but what I'm saying is vector can have a lot of dimensions, right? So in real life, what we deal with is vectors in 3 dimensions, right? In 3 dimensions, because in real life, our life is sort of three-dimensional. So we deal with most of the quantities which have three dimensions, if at all their dimensions are important, right? So let's proceed into understanding the coordinate axis, the coordinate planes, and the three-dimensional space.